Okay, hello and welcome to our first video lecture on and we're going to be starting with chapter 2, talking about determinants. Your book dives straight into determinants of matrices, but I think it's important to first explain what a matrix is and its purpose and so on. So I'm going to do that first. A matrix is usually denoted by a capital letter, for example A. Let me just get my pen working here. Capital letter A, for example, equals, and then we will have a couple of numbers inside: 1, 3, 5, 7, 9, 2, 1, 7, 3. Okay, that's a matrix. Now, the brackets for a matrix can either be the square brackets like I've drawn there, or we can have round brackets. It means the same thing. It's used interchangeably when talking about matrices. And by the way, matrices is the plural of matrix. Okay, so matrix A is a 3 by 3 matrix. Okay, the reason that it's called a 3 by 3 matrix is because it's got 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. And we always talk about row by column. It's always denoted that way. Okay, so inside a matrix, for example, just discussing a little bit more notation, inside a matrix we've got a bunch of numbers. I'm just going to do a 2 by 2 here, A, B, C, D. That's one notation. So those, you've got the capital letter denoting the matrix, and the elements or numbers inside the matrix are denoted by small or lowercase letters here, A, B, C, D in this case. There's also another notation which is a bit more intuitive. Gives you a bit more information. Let's call this matrix B, and we'll denote it as B. Once again, small letters: B11, B12, B21, and B22. See, now what this notation means is the B11 would mean the element of matrix B in row 1, column 1. Here we have the element of matrix B in position, row 1, column 2. Here we have row 2, column 1, and so on. So that's a little bit more, a notation which gives you a little bit more information, which is quite nice. Okay, next let's jump into talking about determinants. So a determinant of a matrix is or at least for a 2 by 2 matrix. So the determinant of a 2 by 2 matrix let's just track back a little bit. Firstly, the notation for determinant. It can be written as the determinant of A, like that, or you can just say you put 2 solid lines, straight lines like that, instead of the curved or square brackets, and you can use that notation. So A, B, C, D. So these 2 lines here mean take the determinant of the matrix inside of those 2 lines. And this means also take the determinant of matrix A. So effectively, determinant of A is equal to, okay, so if A is this matrix over here, then determinant of A, we change out the round brackets, curved brackets for straight lines, and that is A, B, C, D. Okay, then to actually calculate the value of the determinant, one thing that's important to remember is that the determinant is always going to be a single number. So it'll be 5 or 7 or 12, whatever. Okay, So in order to calculate the determinant of a matrix, what we're going to do is take, or rather, for the determinant of a 2 by 2 matrix, what we're going to be doing is we're going to multiply these two elements together and keep a positive in front, and we're going to multiply these, my apologies, it's the switch color there, we're going to multiply these two elements and we're going to stick a negative in front. Okay, so the determinant of A is equal to, now like I said, we're going to multiply these two with a positive in front, so it's going to be plus AD minus, see, we put a minus in front and we multiply those two, so minus BC, and that's then the determinant of matrix A. Okay, fairly simple. Let's just look at a quick example. So so an example being, so example, find the determinant of A, where A is a matrix, and A is given as -2, -3, 5, and 7. Now remember what we said, we're going to, for the 2 by 2 matrix, we're just going to cross multiply. We're going to multiply those two elements, keeping a positive in front, and then we're going to be multiplying those two elements, sticking a negative in front. Okay, and it's as simple as that. So the determinant of A, now one thing to note here is it's best to just keep brackets around each number, and you'll see what I mean by that now. Just keep the brackets there, it's just going to prevent stupid mistakes. Yeah, in maths, just in general, use brackets as often as possible to avoid stupid mistakes. So let's do that. We're going to multiply this diagonal first, sticking a plus in front. So we're going to have plus minus 2 times 7, and then we're going to multiply these two with a negative in front. So we're going to have minus -3 times 5, and that is then equal to -2 times 7 is -14, minus -3 times 5 is that's going to be -3 times 5 is -15, which is equal to -14 plus 15, and that is then going to be equal to 1. And there you've solved your determinant. Okay, and that is the determinant of a 2 by 2. Okay, continuing from the previous video, we're now going to look at the minor and cofactor of a 3 by 3 matrix. Alright, minor and cofactor of a 3 by 3 matrix. So when it comes to doing determinants for 3 by 3 matrices, such as A equals and now I'm going to use the intuitive notation, or as I call it, the intuitive notation, A11, A12, A13, A21, A 2 2, A 2 3, A 3 1, A 3 2, A 3 3. Okay, so when we're trying to determine or get the determinant of this kind of matrix, a 3 by 3 matrix, we need to use minors and cofactors. It's not as simple as a 2 by 2 matrix. Okay, and the process is as follows. Okay, so the first thing that we're going to do is determine the minor of a matrix. Okay, the minor of a matrix is denoted by M. So M I J. Now this refers to the ith row and the jth column. So this was M12. It would be talking about the minor of the first row and the second column. Okay, now I'll explain what that means. So, for example, let's talk about M12. Okay, this is the minor 1 2 is the determinant of the matrix that's derived by deleting row 1 and column 2. So you'll see if you delete row 1 and column 2, so let's delete it. Delete row 1, delete column 2. Okay, you'll see now we're left with a 2 by 2 matrix, and therefore we can get the determinant in the easy way that we spoke about earlier by multiplying these two elements, keeping a positive in front, and then multiplying these two elements by keeping a negative in front. Okay, so the minor 1 2 is equal to the determinant of the matrix that's left behind after deleting row 1, column 2, which is the determinant of A21, A23, A31, A33. And then in order to calculate the actual value, we're going to stick a positive in front and multiply these guys. And we're going to stick a negative in front and multiply these guys. So the value of the determinant works out to be, or the determinant of this matrix here works out to be A21, A33 minus A23, A31, just by taking the determinant of a 2 by 2 matrix. Okay, and that's how you would calculate a minor of a matrix. So, yeah, I don't think there's another example necessary. I hope not. I think it makes quite good sense. So, just quickly, if we were to do the minor, for example, let's do M31. So that would be the determinant of the matrix that's left behind by deleting row 3, column 1. So it's basically this matrix over here, and that matrix, so the minor 3 1 is the determinant of matrix A12, A13, A22, A23, and then we can calculate that using the 2 by 2 method for getting determinants as A12, A23 minus A13, A22. Okay, so that's how we calculate a minor. Okay. Next we need to talk about cofactors. Now the cofactor of a matrix is defined, or let's say denoted first. The cofactor of a matrix, so cofactor of matrix of element. Okay, so the cofactor is taken of an element. So we know that, same for the minor. We take the minor of an element. So the minor of element 1, 2, which is this one, is calculated like that. And the same story for cofactors. The cofactor of an element Aij is equal to -1 to the I plus j times the minor ij. Okay, so let's quickly take a look at that. So here we can so these values, this I and this j, we just add them here and we take -1 to the power of that sum. Now essentially what that translates to is something that I've explained to you earlier, which is the matrix of, or the checkerboard matrix of pluses and minuses. So if you start here and go plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, that is the same as this thing. Okay, so let me prove that to you quickly. If I say find the cofactor of matrix of element A13, okay, element A13. How are we going to do that? Well, first we're going to take -1 to the power of I plus j, which is -1 to the power of I is 1, j is 3. So 1 plus 3 is equal to -1 to the power 4, which is equal to 1. Okay? Now, so +1 essentially. It could either have been +1 or -1. Now, when you've got -1 to the power of a number, if that number is positive, your answer will be 1. If you've got -1 to a negative number, your answer will be -1. Okay, so how does that relate to this matrix over here? Well, if we look at element 1, 3 in this matrix, so row 1, column 3, you'll see that that's also a positive, or +1. So this little matrix tells you what goes in front of 1. Is it a plus or a minus? But if you're more comfortable just doing -1 to the power of I interruption, sorry about that interruption, my software only lets me record 10 minutes at a time. That's something I'm trying to sort out, but I haven't sorted out yet. Okay, so now that we have found the coefficient of the minor, so this is just to give you the coefficient of the minor, meaning should we multiply the minor by a positive or a negative? Okay, so we found the coefficient of the minor. Here it is, it's +1. Now we need to find the minor. Okay, so I haven't even given us a matrix to find a cofactor of. Alright, I've said found the cofactor of A13. So let's just give ourselves a matrix to work here. So I'm going to say that matrix A equals 1, 2, 3, 3, 2, 1, 1, 2, 3. Okay, so remember how we said we find the minor? We're going to, okay, so we need to find the minor of A13. So we're going to delete row 1 and column 3 and get the determinant of that. So the minor 1, 3 is equal to the determinant of the matrix which is left behind after we've deleted row 1 and column 3. So let's delete them. We delete row 1 and column 3, and you can see that the remaining matrix is this one right here. So we're going to take the determinant of 3, 2, 1, 2. Okay, and we're just going to remember, stick a plus in front, multiply those two, stick a minus in front, multiply those two. So that is equal to 3 times 2 minus 2 times 1, which is then equal to 6 minus 2 is equal to 4. Okay, so now we've got our minor, which is minus 4, and we've got the coefficient of our minor, which is plus 1. So now we know, now we've answered our question. The question said find the cofactor of, or find the cofactor of A13. So we've found, first we've done this piece, because here the definition of the cofactor of Aij is negative 1 to the I plus j times the minor ij. And we've now found the negative 1 to the I plus j for matrix element A13, and we know that it's positive 1. We've also found the minor of matrix element A13, and that is 4. So our cofactor, so therefore the cofactor of A13 is equal to positive 1 times 4. And that's it. That's how we do a cofactor. I'm just going to maybe run through one more example of doing a cofactor, if I can find space here on my little writing pad. Apparently not. Okay, let's just clear that quickly. Just open a nice fresh one. Okay, and let's move across a bit. Okay, so let's just do another quick example of doing a cofactor, just to revise it. So the question is, find the cofactor. That COF is not an official abbreviation for cofactor, just so you know. So find the cofactor of matrix, or rather not, let me find the cofactor of element A1, let's make it element A23, okay, and you'll be given the matrix A is equal to 2, 2, 2, 1, 3, 2, 1, 1, 1. Okay, so we need to find the cofactor of A23. So A23 is this element over here, row 2, column 3, row 2, column 3. It's that element over there. And remember that the cofactor, which remember is denoted by A to 3, is equal to negative 1 to the I plus j times the minor 2, 3. Okay? Or the minor I j, which is equal to negative 1 to the 2 plus 3 times the minor 2, 3. Okay? Which is equal to negative 1 to the 5 minor 2, 3 is equal to negative 1 times the minor 2, 3. Okay? So now we've found our coefficient of the minor. Now we need to find the minor. So the minor is what remains after we've deleted row 2, column 3. So let's do it. Row 2, column 3. Okay? So, and remember the minor is the determinant of the matrix that's left behind after we've deleted those two. So, we've got A 2, 3, or the cofactor of element 2, 3 is equal to negative 1 times the determinant of the remaining elements, which are 2, 2, 1, 1. And if we multiply, if we find the determinant of the 2 by 2, you'll see that it's negative 1 times, multiply those two with a positive in front, 2 times 1, stick a negative and multiply those two, which is 2 times 1, and that is equal to 0. Okay? And there you go. You've now found the cofactor of A23. Fantastic. Alrighty. And I think I'm going to end this video here because I'm approaching my 10 minutes. Okay, so in this video I'm going to discuss what your book calls the pattern method of finding a third order determinant. So we're finding the third order determinant, or the determinant of a third order matrix, right? So the question would be something like evaluate two, 1, 1, 1, 2, 1, 1, 1, 1. Okay, so evaluate the determinant, note the straight lines, of this 3 by 3 matrix. Okay, how would we do that? We use what they call the pattern method, and how to do that is fairly simple. All we've got to do is find the minor. So for a 3 by 3 matrix, we're going to find the minor, or actually, in all cases, we are going to find the minors of this top row here. So all of the elements in the top row, we need to find the minors of them. Actually, the cofactors of each of these elements, and then we are going to add that together, and that will be the value of the determinant. So this is where this pattern method comes in that they talk about. The pattern is, remember that checkerboard that I spoke about in the earlier video, plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay? And I'll explain to you exactly where that comes in. But first thing we're going to do is evaluate just the minors. So we're going to take the minor, let me do that in a color for you. So we're going to take the minor of this element, that element, and that element. So first we'll start off with the minor of number of 2, which is the minor of 1, 1. Then we're going to find the minor of this guy, which is row 1, column 2, minor 1, 2, and minor 1, 3, which is the minor of this element over here. So, I wanted to do that in different colors for you. So, let me just fix that up. So, minor 1, 2, and minor 1, 3. Okay, so minor 1, 1 is remember the determinant of the matrix left behind when we delete row 1 and row 1, column 1. So that is equal to the determinant of, delete that row, and it leaves behind this matrix here, which is 2, 1, 1, 1, 2, 1, 1, 1. So we're going to take the determinant of that matrix. We're then also going to take the determinant of the matrix that's left behind when we delete row 1, column 2. So we delete row 1, row 1, column 2, and the matrix left behind is this one. There's the elements of the matrix, because we've deleted row 1 and column 2. So we take the determinant of that matrix, which is 1, 1, 1, 1. Nice and easy. Then we're also going to take the minor of, or the minor of this element, which is element 1, 3, and that is the matrix left behind when we delete that row 1, column 3, and the matrix that's left behind is this one, which is the matrix. So we take the determinant of matrix 1, 2, 1, 1. Okay. So let's quickly take those determinants. So we're going to multiply 2 by 1 with a positive in front, 2 times 1, positive in front, then we're going to multiply those guys with a negative in front. So negative, and we're going to go 1 times 1, which is equal to 2 minus 1, which is equal to 1. And we're going to do the same for this determinant, which is going to give us 1 minus 1, which is 0. Then we're going to do the same for the last one, which is going to give us, stick a positive first, 1 times 1 minus 2 times 1. 2 times 1, which is equal to 1 minus 2, which is equal to minus 1. Okay. Now, the determinant of the 3 by 3 matrix is equal to, so to get the determinant of the 3 by 3 matrix, what we're going to do is we're going to take, you see we took these elements, we took their minors, okay? We're going to use the values of those minors, sticking these symbols in front. Okay, so minor 1, 1. Okay, so now we know the determinant of A is equal to, now remember what I said, we're going to stick this symbol in front of the minor of that element, that symbol into in front of the corresponding element, which is that one, or the minor of the corresponding element, so M12, and we're going to stick the plus in front of this minor, which corresponds to that element. So it's going to be positive 1, right? Which came, so let me just write that a bit better. It's going to be positive M11, then we're going to have minus, because it's M12, so minus M12 plus M13, and then it's quite simple to add it all up, plus 1 minus 0 minus 1. So it was plus 1 minus 0 plus negative 1, which is minus 1, and the determinant is 0. Okay, and that is how you take the determinant of a third order matrix. So I think let's quickly, in the next video I'm going to quickly run through some of the examples in your book, and yeah, cool, see you there. Okay, so in this video I'm just going to run through some examples on the work we've done so far. So I'm going to give you the matrix A. Okay, matrix A is equal to 1, 1, 1, 1, 2, 1, 2, 1, 2. I'm keeping the numbers nice and small here just to make it easier for us to work out, but you can expect something slightly more interesting in a test or assignment. Okay, so our questions are going to be A. Find the minor of A11, and B, we're going to have find the cofactor, or rather just find A11. Now remember, A11 refers to the cofactor of element A11. Okay. And the minor of A11 is M11. Okay. What other questions can we do here? Okay, let's just do those two quickly as examples. So I'm going to start here with question A. Find the minor of element A11, or find the minor of this element, which is also denoted as M11. The minor of element A11. Okay, so let's start with that. Now remember, the minor of element 11, or M11, is just the determinant. So M11 is the determinant of the matrix that's left behind when we delete row 1, column 1. So let's delete row 1 and column 1. There goes row 1, there goes column 1, and we've got 2, 1, 1, 2. Okay? Now we need to take the determinant of that. So that is equal to 2 times 2 minus 1 times 1, which is then equal to 4 minus 1 is equal to 3. Okay, and that's the minor of element 11. Then question B says find A11, or find the cofactor of element small a11. Okay, so remember that A11, or rather, let me write the notation out for you. Aij is equal to negative 1 to the I plus j of Mij. Okay? So, therefore, A 1 is equal to negative 1 to the 1 plus 1 of, or times M11. 1, 1. Okay, is equal to negative 1 squared times m11 is equal to 1 times m11, and we know that m11 is 3 because we already calculated. So it's 1 times 3 is equal to 3. And there you go. That's your answer. The next example, I'm just going to do a quick third order determinant and just walk you through that. So, okay, third order determinant. So, find the determinant of A, given that A equals 1, 0, 1, 2, 1, 1, 0, 1, 1. Okay. Find the determinant of that matrix. Now, remember what we said about finding determinants. Let's quickly draw out our checkerboard matrix, or our pattern board matrix. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Now remember what we said about a 3 by 3 matrix. We are just going to take the minors of the top row. Okay, so each of the elements in the top row. Then we're going to stick these signs in front of the minors, add them all together, and that is going to be our determinant. So let's start. So the first thing we're going to do is we want to find M11, which is the minor of that element. Then we're going to find the minor of this element, which is M12. And then we're going to find the minor of this element, which is M13. Okay, so M11 is the matrix that's left behind when we delete row 1, column 1. So delete row 1, column 1, and we're left with this matrix here. Okay, so we find the determinant of 1, 1, 1, 1. Then we're going to find the determinant of M12, so delete row 1, column 2, and the matrix that's left behind is these 4 guys, 2, 1, 0, 1, so that is 2, 1, 0, 1, find the determinant of that, and then we're going to find the determinant of the, we're going to find the minor of 1, 3, which is the determinant of the matrix left behind if we delete row 1 and column 3, so we can delete row 1, column 3, and what's left behind is these guys. So we need to find the determinant of that matrix, which is 2, 1, 0, 1. Take the determinant of it. So the determinant of that is going to be, or the determinant of this matrix is going to be 1 times 1 minus 1 times 1 equals 0. Then the determinant of this matrix here is going to be 2 times 1 minus 1 times 0, which is going to be equal to 2. And the determinant of our last matrix here is going to be equal to 2 times 1. Ooh, something's wrong here. Sorry, I made a little mistake there. Let's just quickly erase that. Okay. My bad. I actually need to erase a little bit more. I put the wrong things into this matrix. I'm sure you spotted it. The matrix here is what's left when I delete row 1 and column 3. Dip, dip. So it's this matrix here, which is 2, 1, 0, 1. Oh no, it wasn't a mistake. My bad. It's just that these two matrices are the same. It confused me a little bit, but they are it is fine like that. 2, 1, 0, 1. So the determinant, because these matrices are the same, the determinant here will also be 2. Now we need to take the very quickly, we're going to stick the appropriate signs in front of the minors that belong to each of these elements, add it all together, and then we will have our determinant of the 3 by 3 matrix. So the determinant of A is equal to positive times M11, so plus M11 minus M12 plus M13 is equal to plus 0 minus 2 plus 2, determinant equal to 0.